Hello and welcome back to another video. Today I will be showing you my Raymarching code. The version I made is called circle tracing, but what is Raymarching even? Well, Raymarching is a way of finding an intersection with a surface by marching along a ray. To be a bit more specific, it works by stepping along a ray with a small increment until we hit a wall. One of the better versions of this is circle tracing, which is where we dynamically calculate the step size. The way it works is that we find the distance to the nearest object and then take that long of a step along the ray. Then when our step gets really small, we know that we hit our surface. But how do we find the distance to the nearest object? Well, we do this with a signed distance function. The basic idea is that we give it a point and it returns the distance from it to the edge of the shape. This means the distance will be negative when the point is inside the shape, positive when the point is outside, and 0 when the point is right on the edge. There are tons of signed distance functions out there, both 2 and 3D versions, but for my example I will be focusing on spheres. Let's take a look at some code which should make it a bit more obvious how it's implemented. The first thing we should look at is the actual signed distance function, which for a circle is super simple. We get the distance between our point and the center of the circle and just subtract the radius. Finding the distance between 2 points is just a slightly modified version of the Pythagorean theorem. We first calculate the length of the adjacent side by subtracting the point's x value. Then we do the same for the opposite side but with their y. After that we just use the standard method of squaring the numbers, adding them together and taking its root. Next we need to find out how to step along our ray, which actually is a lot easier than you might think. We start by calculating the fraction of the whole ray which we are stepping along. Then we calculate the x position we would be placed at. After that we just do the same for the y and return our result. And that's basically it. You could of course change the SDF to that of any other shape. You can even mix them or come up with your own. There will be a raylib-based C implementation in the description. Please like and subscribe to help me grow. See ya!